Intermediate Algebra, Section 7.8. Negative numbers do not have square roots in the real number system. However, a large number system that contains the real number system is designed so that negative numbers do have square roots. That system is called the complex number system. The complex number system makes use of I, a number that is, by definition, a square root of -1. So here we have the number I. It's telling us that I is the unique number for which it is equal to the square root of -1. And if we square both sides, I squared is equal to -1. We also have something called the imaginary numbers. An imaginary number is any number that can be written in the form of a plus bi, where a and b are real numbers and b does not equal 0, which would take out the number I. Further, we have a union of all set of imaginary numbers and the set of all real numbers. It's called the complex numbers. A complex number is any number that can be written in the form of, just like we saw before, a plus bi, but with the definition or restriction where a and b are real numbers and a and b both can be 0. We now can, with the definition of I, we now can define the square root of negative numbers. Here in this first example, they're asking us to take the square root of -36. We can think of this as -1 times 36. Separating this, we would have the square root of -1 times the square root of 36. Square root of -1 by definition is I. Square root of 36 is 6. And the general form, so that there's no confusion, especially if we didn't have a perfect square root, we put the integer or the number first and I second. In this next example, they're asking us to take the square root of -72. We can break this down into factors, getting rid of the -1 to start with, and then 72, since that is 2 times 36, into factors that we can simplify this radical, and taking the square root of each one of those factors allows us to simplify this further. Square root of -1 is going to give us an I. Square root of 2 we can't do anything with, but square root of 36 is 6. So putting them in order, we will have a 6 from the square root of 36, and I, and the square root of 2. It's just so that we have no confusion that the I is underneath the radical, that we put it in front of the radical. We also could have put 6 square root of 2 as our answer with the I, but just to make sure that the I, it's clear, is not under the radical. Simplifying this next expression, these aren't similar terms. This is an integer, this is a radical, but we can simplify the square root of -5 now that we have the definition for I, which can replace the square root of -1. So leaving the 4 alone, but square root of 5 can be thought of as -1 times 5. Splitting that into the square root of -1 times the square root of 5, and in place of square root of -1, simplifying further, we can put our I because of its equal value. And again, here it's clear that the I is not underneath the radical, but if we're looking to put this in complex number form, which is a plus bi, we could rewrite this as 4 plus the square root of 5 times I. We also can add and subtract complex numbers, and you can think of these just like we do binomials. it is customary to write the results in the form of a plus bi. So in this first example, they're asking us to simplify this. It's addition, so parenthesis has no effect. We are going to combine the like terms. And just to illustrate the combination, I'm going to rewrite the order, putting the like terms together. I have a plain integer and another plain integer from the second number. I have a negative 4i and a negative 5i. Almost wrote another 4. Simplifying by combining the like terms, negative 10 plus 6 will leave us with a negative 4. Negative 4i minus 5i, or plus a negative 5i, leaves us with a negative 9i. So very similar to combining binomials and simplifying like terms. In this next one, we have a complex number minus a complex number. We have a subtraction of a quantity, and using the rule of subtraction, which is equivalent to a plus a negative b, we can use this rule when we have a subtraction of a quantity, so that we're sure that we remember not only to subtract the first term, but also to subtract the second term. I will turn this into an addition of the opposite of what the signs were. Now it's essentially like the example above, where we're going to combine the non-imaginary numbers, which is a 4.8 plus the negative 2.6, and then combine the pure imaginary numbers here, which is a negative 1.7i plus a 4.8i. Combining here on our values, 4.8 plus a negative 2.6, or subtract 2.6, leaves us with a 2.2. And in terms of our imaginary portion of our complex number, negative 1.7i plus 4.8i will put us on the positive side of a 3.1i, leaving our answer in that complex number system of a plus bi.